Hey, what's going on, Alex Bros? It's Mr. C here, and in this video, I'm going to show you how to solve a polynomial inequality. Here we have solve x squared minus 7x is less than or equal to negative 10. First thing you want to do is make one of the sides 0 here, and the easiest way to do that is to maybe bring this negative 10 over to the left-hand side. That gets us x squared minus 7x plus 10 is less than or equal to 0. I want to pause for a moment and focus on the less than or equal to 0. What that means for us is that we want to figure out what values of x make the polynomial on the left, which is quadratic by the way, negative or 0. So I'm just going to indicate that we want to be on the hunt for values of x that make the polynomial negative. So where do we go from here? Well, what you want to do is see if you can factor to the left-hand side polynomial, and we definitely can do that. We're looking at x minus 2 times quantity x minus 5. Those are factors of positive 10 that add up to negative 7. Next, what we'll do is imagine this inequality as if it were just an equation, and this helps us solve for x. In this way, we can set x minus 2 equal to 0, and also set x minus 5 equal to 0, in which case we get two values of x equals 2 and x equals 5. So these are the two values, and the only two values that actually make the polynomial on the left 0. They don't make it negative, they don't make it positive, so we are still not really finished because, we only have the values of x that make the polynomial 0. We also want the values of x that make the polynomial negative. So where do you go from here? Well, what you want to do is go ahead and draw a number line and place those two values on the number line to create what's going to be three regions of the real number line. And from each of those three regions, we're going to pick a random value and decide, is it going to make our polynomial negative or is it going to make our polynomial positive? So I think one of the easier ways of doing this is to do a sign chart. What I'm going to do is right underneath here, make a little table. And hopefully I made that large enough. There are going to be 3 columns to this table. There's going to be 4 rows. The first row is going to be kind of like a little skinny row there, but then I'm going to have a few other rows underneath that. What I'd like to put right here is the number 2, which is one number helping to make these 3 regions, and then 5, which is another number helping to make these 3 regions. Now, to the left of this table, next to the second row, I'm going to put the factor x minus 2. Right underneath that, for row 3, it's going to be the factor x minus 5. And then the last row consists of the product x minus 2 times x minus 5. Now what we should do is pick some values from each of the 3 regions and figure out what does it make each factor. Does it make it positive? Does it make it negative? And then what would that ultimately mean if we were to multiply the 2 factors together? So I'll go in order from left to right. I'm looking at the region that's to the left of 2 on the number line. An easy value to pick from there would be 0. And if you plug 0 into the factor x minus 2, you get a negative value. In particular, negative 2. If you plug 0 into the factor x minus 5, you get negative 5, in which case that's a negative value. But when you multiply x minus 2 to x minus 5 with 0 plugged in, you get a negative times a negative, which gives us a positive. What that means is that any value of x that we plug in that's less than 2 is going to make the polynomial positive. Let's move on to pick a value between 2 and 5. I don't know about you, but I'm thinking about 3, so I'm going to plug 3 in. to each factor. If we plug 3 into x minus 2, we get a positive 1, which is a positive number. If we plug 3 into x minus 5, that gives us negative 2, which is a negative number. Now what happens if we multiply a positive to a negative? We get a negative. So what that means is any value between 2 and 5 that we plug in for x into our polynomial is going to make it negative. So I'll indicate that region by a bunch of minus signs. Last but not least, let's pick a number that's larger than 5. That would be a number from the third and final region there. Maybe 6 is a good number to go with. If you plug 6 into the factor x minus 2, you get 4, which is a positive number. If you plug 6 into the factor x minus 5, you get 1, which is also a positive number. And if you multiply a positive number to a positive number, you get a positive number. So that means any value of x that's larger than 5 that we want to plug into a polynomial is going to give us a positive result. Now, keep in mind that we want values of x that make our polynomial negative. The number line gives us a visual as to which values of x those would be, and those would be values of x that are between 2 and 5. So lots of numbers between 2 and 5. We don't want to just put 2 and 5 or 2, 3, 4, 5, so on and so forth. We have to include all the decimals and whatnot. So in other words, we're going to use interval notation to represent that little section of the number line. We'll use 2 as a smaller value from the number line, comma 5. And keep in mind the inequality symbol had a bar underneath it. So that means that we'll include each of these two endpoints. For interval notation, what that means for us is we're going to have to surround each of those two values with brackets. And that, my friends, is how you solve this polynomial inequality. If you have any questions about this whatsoever, feel free to reach out to me. Otherwise, thanks for watching. I'll see you in the next one.